my name is Mira, and I'm a PhD student at the University of Georgia. Every year, we produce a lot of plastic waste. A research report, global annual plastic waste generation is expected to grow to almost 700 million tons by the 2050, with the majority ending up in the landfills. And my PhD research is focusing on this. Bioplastic is one of our best hope for changing that, but there's a catch. Biodegradable, it doesn't mean that the material will simply disappear. It actually depends entirely on where the materials ends up. One of the most common bioplastic only breaks down in industrial composting facility and will not degrade naturally in someone's backyard. Commonly adopted but inefficient method is empirical tests of degradability, which this one usually takes up to 12 months, a year. That's far too slow to test new ideas. So my first goal is to speed this up. First, I lock a fluorescent dye inside the bioplastic. Then I add enzymes from a specific environment, like soil or compost. If these enzymes can cut through the polymer chains, the dye inside is released and will be detected. The materials reports on its own breakdown. I can evaluate the percentage and the speed of degradation. And the best part, the whole procedure is happening in just 3 days. And degradability is only part of the story. For a bioplastic to truly replace a conventional plastic, it must perform just as well. But many are either too brittle or too soft to be useful. A polymer is made up of many long, tangled molecules that resemble chains. If the polymer is heated and stretched, the chains can rearrange into highly ordered structure, fundamentally changing the material's properties. The result is a material that is much stronger and far better at blocking the oxygen and moisture, something that food packaging, medical, and pharmaceutical industries require. This approach is well known for conventional plastics, such as polypropylene, but little research has been done with biodegradable plastic, mainly because it requires complex and expensive equipment intended for industrial use only. But now, in our lab, we built a custom machine that works just as well as the industrial one, making research far more accessible. However, making bioplastic stronger can also make it harder to break down and compromise degradability. An ability to perform quick screening combined with development of novel biopolymers is the core of my research. As someone who grew up in Vietnam, I saw plastic bottles floating in the local rivers with my own eyes. I truly believe that my research can open the door to truly sustainable single-use materials, products where how well a material works and how cleanly it disappears. Both truly matters. Thank you.